Okay, so let's look at this hypothesis test, which uses the p-value. You wish to test the following claim that the alternate hypothesis, or the following alternate hypothesis at a significance level of 0.005. We have that for the null, the mean is 58.1, and for the alternate, the mean is greater than 58.1. The population is normally distributed. We know the standard deviation is 15.3, and the sample mean is 59.4 with a sample size of 67. We want to know, first of all, the test statistic, then the p-value, and then we'll make our decisions about the test. All right, so let's do the test statistic, and I believe I can write right here on the screen. I'm going to try to anyway. All right, so since our sample size is large and we have the population standard deviation, we're going to use the z-score. And recall our formula is to take the sample mean, 59.4, subtract off the mean from our hypothesis, 58.1, and we're going to put that over the standard deviation, 15.3, over the square root of the sample size, which is 67. Okay, so on top, I'm going to get, looks like 1.3, and I will put the bottom into my calculator. Okay, and that is 1.869192. There's actually a few more decimal places, which I will keep when I'm doing but I'm going to run off of my little presentation screen if I put more. So, but you can check, of course, and make sure you get exactly the same thing. And that gives me 0.69548. 8, that's probably enough since again, I'm going to run off the screen there. All right, and that is my test statistic. All right, now I want to do the p-value from that test statistic. All right, so it erased my drawing as I went to use another screen, but that's okay. I've got it written, or I've got it actually here in my calculator. All right, so our test statistic, we're going to take it and we're going to put it into Excel. And remember, I said we're using the z distribution, so we want norm.s.dist, and our value was 0.695488. And then I want to put true, and I hit enter, and I get this. Now, we've got to realize that our alternate is right-tailed, so in order to get the p-value for a right tail, we'd have to subtract what we get from 1. So I'm going to go ahead and subtract this answer from 1. And that gives me the actual p-value, which is 0.243375. All right, so 0.243375. Our alpha, I'm going to flip away from it, was, where is it? Oh, it's 0.005. 0.24, whatever we had there, 0.24, is definitely bigger than alpha. All right, so the p-value is greater than alpha. And if it's greater than alpha, we're going to fail to reject the null. It has to be smaller than alpha to reject the null. So we're going to fail to reject. And then on that same one, if we fail to reject, that means there's not enough evidence to accept that alternate hypothesis. So if we look among ours to find where there's not enough evidence to support the alternate, there's not sufficient sample evidence to support the claim that the population mean is greater than 58.1. So there's not evidence to support our alternate that says that the mean is greater than 58.1. So it would be this last one. So hopefully that will help you with these p-value tests.